Are you smarter than your ancestors, or at the very least, students from 100 years ago? Well, that's a question that you'll be able to answer for yourself in this video, as we are going to look at two SAT math problems from the first SAT exam way back in 1926. If you're familiar with the format of the questions on today's exam, then you'll notice a fair amount of differences, but whether or not you'll be able to solve these vintage problems is another question. So with that out of the way, let's get right into the math. I'm really glad you're here today. This first problem here says the following. What is the cost of 2 cans of spray if each can contains 2.5 pounds and the price is 5 cents an ounce? At first, this problem seems pretty confusing because there are a lot of moving parts. We have pounds, ounces, price, a lot of different units. But we're going to use a technique that will allow us to convert the units one piece at a time to make this problem a lot simpler. Specifically, we're using what's called the factor labeling method. While I could explain factor labeling in more detail, I think it'll be easier if you just watch how I solve this problem with this process. We're going to start with the fact that we have 2 cans of spray. I'm going to write 2 cans here, and our goal is to get to the price. So our final unit should be cents or dollars. We're starting with cans and we want to end with cents or dollars. What we're going to do is just write different products that are going to do each piece of the conversion. In this first conversion, we're going to convert cans to pounds. We're going to figure out how many pounds of spray we have. So here I'm going to write 1 can in the denominator. And we know that 1 can contains 2.5 pounds of spray. We want can in the denominator here because now this unit is going to cancel. And with this, we have the amount of spray we have in pounds. So again, so far we've converted cans to pounds. In this next step, with the next fraction I'm going to write, we're going to be converting pounds to ounces. This piece of information was also given to us in the problem. We know that in 1 pound, again, I'm writing pound in the denominator because I want it to cancel with a pound in the numerator in the previous fraction. So in 1 pound, we have 16 ounces. Again, cancellation of the pounds. And at this point, we have the total amount of spray in ounces. And then our last conversion is just converting the ounces to cents. We're given that the price is 5 cents an ounce. I want to put ounce here in the denominator so it cancels with the ounce in the numerator from the previous fraction. And up in the numerator here, I'm going to write 5 cents. Once again, ounces is going to cancel. The previous unit we had canceled. And from here, we could convert the cents to dollars, but I'll just stop the process at this point to make things simpler. But once we simplify this expression, we'll have the total cost of the 2 cans of spray in cents. By the way, you don't need a calculator to simplify this. All right, I'm just going to go from left to right here to simplify. 2 times 2.5 is 5. And then 5 times 16 is 80, right? Because if you break up 16 as 10 and 6, well, 5 times 10 is 50. 5 times 6 is 30. 50 plus 30 is 80. And then 80 times 5 is 400. 8 times 5 is 40. So 80 times 5 is going to be 10 times that, or 400, which means that the total cost in cents is 400, or just $4, $4. Overall, in terms of difficulty, I would say this problem wasn't horrible. If you're not familiar with unit conversions, then this could have definitely been more difficult for you, but otherwise it's just a matter of breaking the problem down into smaller steps to get your desired answer. I will say, however, that the next problem we're looking at is slightly more involved. So pay close attention here and let me know what you thought about this first one. In the second problem, we're looking at horses and mules. This problem says the following. A dealer bought a lot of 3 horses and some mules for $600 and sold the lot for $820. If he gained $40 on each horse and $50 on each mule, how many mules were there? So the objective of this problem is figuring out how many mules the dealer had, given that he originally had 3 horses and some mules that he sold for a profit. Specifically, we're given the amount of profit he made on each animal, right? We're given that he gained $40 on the horse and gained $50 on the mule. So the first step should probably be figuring out the dealer's total profit. The dealer's total profit is going to be $820 minus $600 or $220. At this point, we want to figure out specifically how much profit the dealer made in total from the mules. Because once we have that, we can just take that value and divide it by 50 to find the total number of mules there were. In order to find the total amount of money the dealer made from mules, you have to take this $220 number, the total profit, and subtract from this the profit the dealer made from the horses. But we're going to have to figure out the profit the dealer made from the horses. This number is just going to be 3 times 40. Since the dealer had 3 horses and he made $40 in profit from each horse, this is just going to be $120. So the profit from the mules is just going to be $220 minus $120, which is $100. And since we know that the dealer made $50 from each mule, that means that there had to have been 2 mules because 50 times 2 is 100. Now, I would say the most important detail to this problem was this word gained here, which is easy to miss, I feel. The gained here meant profit. So you were looking at the profit. Thank you so much for watching until the end. How many problems were you able to solve correctly? Let me know in the comment section. And also let me know if you have any suggestions, feedback, or questions otherwise. But if not, I will talk to you in the next video. Bye now.